Okay, so now this code's going to be quite a bit more complicated than any of the code that we've looked at before.
Yeah.
Which is fine. This is a more complicated situation than we usually look at. But well, first of all, what do you see in the code?
Well, the first thing I notice is that I think it's a surprisingly little amount of code. It's still complicated, but I would expect a lot longer program for something like this.
Yeah, that's a great point. Like if we sat down and tried to write this not knowing at all what we were doing, we'd probably have a very, very long program. Yeah. He knows what he's doing, so he's able to take advantage of a lot of Mathematic's power. But yeah, so that's a great observation. What do you see?
Well, it looks like whatever this EP is probably the center point here, this gray dot, and maybe this MP is where all of the colored dots start at the point, because they'll start up here. So maybe that's the point 0.5.
Okay.
I guess this here is probably the acceleration that's calculated for each one. Maybe that's I'm not sure. Maybe movement.
It's probably momentum.
Momentum. So I guess these two, maybe they're used.
I shouldn't say for sure.
Well,
I actually didn't look at what it's doing, but yeah, it's just some variable.
So I guess down here, this kind of calculates how each one of them moves, and it's kind of cool that they don't have 3 separate functions. For each one, they can do it all with one. They can calculate them simultaneously.
Yeah, that's actually pretty neat. You're right.
Maybe that's a matrix. I'm not sure. Maybe they use matrices.
It's certainly using vectors for sure.
And then I guess here's where they set up the table.
Do you see the 1 over r squared, 1 over r to the 1.9, and 1 over r to the 2.1 anywhere?
I think that's... Yeah, here's the 2, here's the 1.9, and then here's the 2.1.
Okay. All right. Well, let's change them. What would you like? What could we change it to?
We could make it slightly more drastic, and could maybe go down to 1.5.
All right.
And up to 2.5. I can't really
Here, I'll get
see the mouse.
Up to 2.5. Okay.
Yeah, it's possible that if this amount by which it deviates gets too large, then like the purple one might get flung out of orbit and the orange might just drift away.
Looks like we have to change it down here to 1.5 and 2.5. Do you see any other 1.9s and 2.1s anywhere in the code?
I don't.
No. 2.
There's a 1.9. That's just in the text. That's for the down there. So but we'll change it. 0.9.
And then there's a 2.1.
Okay, now this takes a little bit of time to run, but it's fine. So hopefully we got them all. Let's just do a quick check. All right. What do you think we're going to see when this runs? So what's your expectation of what's going to happen to the 1.5?
I think it's eventually going to drift very close to the central point, and then orbit's going to suddenly change very quickly, and then it's going to get flung out of its orbit really far.
Oh, wow. Okay. What do you...
Yeah, I think the purple one is probably going to be moving very fast, or it might get flung out. I think it's about to run, and then the orange one can just...
Yeah. The orange just drifts away. There's not enough force to hold it.
That's kind of interesting, though. It's kind of has 5 separate orbits, and it's just rotating more. It's rotating more between the orbits, and then they kind of all merge into one.
It's eventually filling in into sort of a torus shape or something like that.
But it's interesting that this one, it doesn't get flung away. It still is, I guess, because the gravity is so strong that it's still pulled back in.
Uh-huh.
I wonder if we can increase the time, like.
Oh, how long it runs? You wanna see how that shape fills in?
Yeah, so if we just pause it and then go all the way to the end, it starts to form this donut hole shape here.
Oh,
It
neat.
never gets in this range, which is interesting.
Yeah. Oh, so maybe there'd be some way to calculate that inner circle and outer circles radius.
Mm-hmm.
Yeah, that's a great observation. All right, guys. So this was fun. This was
Yeah.
fun to play with.